The ocean floor is not silent. Right now, nearly a mile beneath the cold black waters off the coast of Oregon, something is swelling. Sensors anchored to the seafloor are registering pressure. Subtle, steady, unmistakable. And scientists monitoring those signals are asking a chilling question. Is a volcano waking up directly beneath the Pacific Ocean? Because deep below the waves lies a massive underwater giant most people have never heard of. Yet it may be one of the most closely watched volcanoes on Earth. Its name is Axial Seamount. And it's rising. Far beyond the shoreline where fishing boats disappear into fog and the horizon swallows light, the Pacific hides a landscape more alien than any desert or mountain range. Down there, darkness is permanent. Pressure is crushing. Temperatures swing from near freezing to scalding. And in that darkness stands Axial Seamount, a colossal submarine volcano, roughly the size of Mount Rainier, but flattened, submerged, and hidden from sight. It sits along the Juan de Fuca Ridge, a seam in Earth's crust where tectonic plates slowly pull apart. Magma rises here constantly, creating new ocean floor inch by inch, century after century. To the untrained eye, it sounds calm, predictable, geological routine. But scientists know better, because Axial Seamount is not just any volcano. It's one of the most active underwater volcanoes on the planet. For years, researchers have watched it like doctors monitor a patient's heartbeat. Instruments anchored to the seafloor measure tiny changes in pressure. Seismometers listen for tremors. Thermal sensors detect faint shifts in heat. And recently, something changed. The numbers began to climb, not fast, not dramatically, but steadily, persistently. Pressure readings showed the seafloor slowly inflating, as if something deep underground were pushing upward, stretching the crust from below. To most people, that might sound abstract. To volcanologists, it means only one thing. Magma is rising. When molten rock gathers beneath a volcano, it doesn't always erupt immediately. Often it accumulates slowly, filling underground chambers like air filling a balloon. The surrounding rock flexes. The seafloor bulges upward, sometimes only by centimeters. But those centimeters are everything, because they are the earliest warning signs of an eruption. Scientists studying Axial Seamount noticed the pattern almost immediately. The inflation curve looked eerily familiar. It resembled the same pressure build-up recorded before previous eruptions. In other words, this had happened before, and last time it didn't end quietly. The Earth's crust beneath the Pacific Northwest is a dynamic battlefield of forces. Here, tectonic plates grind, slide, coalesce, and separate. The Juan de Fuca plate is slowly moving away from the Pacific plate, creating a spreading center, a crack in the planet's skin. Through that crack, magma rises continuously from Earth's mantle. Most of the time, the process is slow and uneventful. Lava oozes out gently, hardens, and becomes new crust. No explosions, no ash clouds. Just silent creation. But occasionally, pressure builds faster than it can escape. When that happens, the crust fractures, and the seafloor erupts. Unlike volcanic eruptions on land, underwater eruptions don't produce towering plumes of ash or rivers of glowing lava racing down slopes. Instead, they unfold in darkness, hidden beneath hundreds of meters of water. Yet they can be just as dramatic. Now, during a submarine eruption, fissures rip open across the ocean floor. Lava pours out like liquid metal, instantly cooling into bulbous formations known as pillow lava. Steam flashes, minerals crystallize, entire sections of seabed can shift or collapse. And all of it happens silently. At least to human ears, but not to instruments. When Axial Seamount last erupted in 2015, scientists recorded thousands of tiny earthquakes in rapid succession. The seafloor sank as magma drained from its chamber. Lava flows spread across miles of seabed. It was one of the most precisely documented underwater eruptions in history, and it revealed something astonishing. Axial doesn't erupt randomly. It erupts on a pattern. Researchers analysing decades of data discovered that each eruption was preceded by a measurable inflation phase. Pressure built. The seafloor rose. Then, once a threshold was reached, the system released, like a valve opening. Now, that same inflation pattern is happening again, which raises a question scientists can't ignore. Is Axial Seamount preparing for another eruption right now? To understand what's happening beneath the volcano, you have to imagine the planet's interior not as solid rock, but as a slow-moving engine of heat. Deep inside Earth, temperatures exceed 7,000 degrees Fahrenheit. Rock melts. Convection currents churn like boiling water. Hot material rises while cooler material sinks, driving tectonic motion across the surface. Axial Seamount sits directly above one of these upwelling zones. Magma accumulates in a reservoir beneath the volcano, gradually pressurizing the crust above it. As more molten rock enters the chamber, the pressure increases, the ground lifts, the crust stretches, faults weaken, eventually something gives. Scientists monitoring Axial use an advanced network called the Regional Cabled Array, a system of underwater cables linking instruments directly to shore. It streams real-time data from the seafloor to laboratories on land, allowing researchers to watch geological processes unfold as they happen. It's like having a live broadcast from the Earth's interior. And what that broadcast is showing now is tangent. Pressure levels are approaching those measured just before past eruptions. Seismic tremors, though small, have begun to appear more frequently. The volcano isn't exploding. It isn't roaring, it's breathing. Slowly, heavily, like something gathering strength. But what would happen if Axial erupted again? The word eruption often conjures images of catastrophe, fiery explosions, shockwaves, destruction. Yet underwater eruptions behave differently. The immense pressure of the ocean suppresses explosive force. Lava tends to flow rather than detonate. So in most cases, an eruption at Axial Seamount would not be dangerous to people on land. It wouldn't trigger tsunamis or devastate cities. It would unfold quietly, miles offshore. But that doesn't mean it's insignificant, because what happens at Axial doesn't stay at Axial. Submarine eruptions reshape the ocean floor. They release heat, chemicals, and minerals into seawater. They create hydrothermal vents, fissures that spew superheated fluids, rich in metals and nutrients. Around those vents, entire ecosystems thrive. Strange life forms that don't depend on sunlight. Tube worms, ghostly shrimp, bacteria that feed on chemicals instead of light. Every eruption rewrites the hidden world. Old habitats are buried, new ones are born. Life dies. Life begins again. All in darkness, the history of Axial Seamount is written not in textbooks, but in rock layers and seismic waves. Evidence suggests it erupted in 1998, then again in 2011, then in 2015. Each eruption followed a similar pattern. Gradual inflation, increasing seismicity, and then sudden release. To volcanologists, that pattern is gold. It means the volcano is somewhat predictable, a rarity in the chaotic world of geology, and now, once again, the data is tracing that familiar curve. The seafloor is rising, the pressure is building, time is ticking. Yet, not all scientists agree on what will happen next. Some believe the current inflation trend strongly suggests another eruption is imminent, perhaps within months or years. Others argue the system could stabilize, releasing pressure gradually without a major event. Volcanoes, after all, are notoriously unpredictable. Even with cutting-edge instruments and decades of data, Earth still holds the final say. That uncertainty is what keeps researchers watching day and night. Because the moment pressure crosses a certain threshold, everything could change instantly. Why does this matter to the rest of the world? Because Axial Seamount isn't just a local curiosity, it's a natural laboratory, one of the few places on Earth where scientists can observe the full life cycle of a volcano in real time. Most volcanoes erupt without warning. Many lie in remote or dangerous regions, but Axial is wired with sensors, mapped in detail, and constantly monitored. It's giving researchers a rarer opportunity to understand how eruptions begin, to decode warning signs, to refine forecasting models. Knowledge gained here could one day help predict eruptions elsewhere, including those that threaten cities and millions of lives. In that sense, this hidden volcano beneath the Pacific may hold clues that protect people across the globe. Still, mysteries remain. What determines the exact moment magma breaks through? Why do some pressure buildups lead to eruptions while others fade away? How does magma move through crust that appears solid and immovable? Each data stream from Axial adds another piece to the puzzle. Each tremor is a message from below. Each millimeter of uplift is a signal. The Earth is speaking, scientists are listening, but they don't yet understand every word. Right now, beneath nearly a mile of ocean water, molten rock is pressing upward against the crust. The seafloor above it is flexing, slowly rising like the chest of a sleeping giant drawing breath. No one on shore can feel it. No satellite can see it directly. Yet, it's happening, quietly, relentlessly. Somewhere deep below, pressure is building toward a decision point written into physics and stone. At some unknown threshold, rock will fracture, magma will surge, and the ocean floor will split open once more. Or it won't. That's the tension. That's the mystery. That's why scientists can't look away. Because Axial Seamount is not just a volcano. It's a reminder that beneath the calm surface of our world, forces older than life itself are always in motion, always shifting, always shaping the planet we stand on. We build cities, we draw borders, we imagine stability. But far below, Earth is still creating itself. And tonight, as waves roll quietly across the Pacific, as fishing boats drift under the stars, as coastal towns sleep peacefully along Oregon's shore, a mountain no human eye can see continues to rise in the darkness, waiting, breathing, building. The question is not whether Axial Seamount will erupt again. The question is, when? Nearly a mile beneath the Pacific Ocean off Oregon's coast, Axial Seamount, one of the world's most active underwater volcanoes, is showing signs of awakening. Instruments on the seafloor have detected a steady pressure increase and subtle swelling of the ocean floor, a signal scientists recognize as magma accumulating beneath the crust. This pattern closely mirrors the same warning signs recorded before Axial's previous eruptions in 1998, 2011, and 2015, when thousands of earthquakes and lava flows reshaped the seabed in total darkness. Unlike explosive land volcanoes, Axial erupts quietly under crushing ocean pressure, but its activity is scientifically invaluable. Connected to shore by real-time monitoring cables, it serves as one of the only volcanoes on Earth that researchers can watch continuously as it evolves. The current inflation suggests the system is approaching a critical threshold. though experts remain divided on whether an eruption is imminent or if pressure will stabilize. What happens at Axial matters far beyond the Pacific. Studying it helps scientists decode eruption warning signs worldwide, improving forecasting for dangerous volcanoes near populated regions. Hidden beneath cold black water, the volcano continues to rise slowly. A reminder that Earth's most powerful forces are always moving, even when the surface seems calm.